Alright, so I wanted to go ahead and solve this last little homework on the problem set. So here we go. We have in the first part, we have a tennis ball that is served with a horizontal initial velocity. And it is served at a height h. And the net is this level h high. And it's got a position x here, and we'll say x naught is 0. We'll say x is 12. The height here is 0.9. This is 23.6 meters per second. And this height here is 2.37 meters. So we want to know if the ball will clear the net. So the real question here is, does the ball drop, so the difference between h and little h, 2.37 minus 0.9. So we want to know if the ball drops 1.47 meters in the time that it travels. So let's find out. So let's get the time it spends going horizontally. So that's x equals v naught t plus x naught. There's no 1/2 at squared term. So we have 23.6 times the time plus 0 equals 12. So 12 over 23.6. That's the time that we're reckoning with. And that's 0.51 seconds. Now let's see how far it falls in that time. X is 1/2 gt squared. Well, that's y equals 1/2 gt squared. And let's see how much it was. So 1/2 times 0.51 squared times 9.81. So we can even go ahead and square this. Times 0.5 times 9.81. So it falls 1.27 meters. Fallen. So yes, it does clear the net. Now, what is the distance between the center of the ball and the top of the net? That's going to be 1.27 minus 0.9, because that's the distance it falls, and that's going to be 0.37 meters. And then the ball is served 5 degrees below the horizontal. So we have a little bit more of a calculation to do, so let's just see. So we have 23.6 times the cosine of 5 degrees to get the speed. So 23.6 times the cosine of 5 times pi over 180 on the Mac. So we're going at a speed of about 23.5 meters per second. And so the time to cross might actually be a little bit more. That's 12 over 23.5. Let's just see what we get with that. Still getting 0.51. So to within a decimal place, that works, but now let's look at what's happening in the y direction. In the y direction, we need to see what's happening with the following. So we have 1/2 9.81 times 0.51 squared plus 23.6 times the sine of 5 degrees times t, which is 0.51. So let's just double check and see what that falling speed is. So we have here 23.6 times the sine. So that's actually 2.02. And we times that by, so that's 2.02 times 0.51. Y is 1/2 9.81 0.51 squared plus this extra part. So we already got the falling distance in the first part, so we can use that in this calculation as 1.27 plus whatever we have here, which appears to be 2.02 times 0.51. So we're getting 1.04. That little angle makes a big difference. So it actually falls 2.31 meters. So the answer is no, it doesn't clear the net. So interesting. So that's part C. Now what is the distance between the center of the ball and the top of the net? Let's be clear. That's going to be 0.9, and then 2.31 is what it falls. And so we end up getting 2. Well, what's interesting here is to hit the ground it would have needed to fall 2.37. It's like 6 centimeters from the ground here, and it's actually about 2.22 from the net, from the top of the net. It's actually almost hit the ground. So that's question number 3.